Good, I think it's working now. So what I'll be doing today, just a bit of a shorter video. I just wanted to actually do an example with paint on the equation that I built up yesterday, just to make sure that this works well. Wait a second, I think I got, again, the same problem with the mouse. Yeah, okay, cool, now it works. So we had, basically, I think we had, what did we have? I forgot what we had, what we were calling. So I think we're saying C, A, C, B, X, Y, based on what I'm seeing here. And then this is being transformed into E, D, right? And what? Sorry, no full screen needed for that. Yeah, and we're trying to figure out what's these here, right? And so the idea is that it's supposed to follow these equation. I mean, it's just like if you work it out from here, right? You basically, if we call these, the result, then you basically get that, E times D times the result should be the same like X times A times C plus B times Y times C, right? And so we know that E equals C, and we know that D equals there's something I think I did. I don't know if that's correct. 2 times the inverse of E. I don't think that is. I think I called that differently all the time. Where did that go? Okay. So what I was calling E is the result. For the state being equal. For the state being non-equal, no, the other way around. Okay, I call these D and these E. Okay, but then I said D equals C, which is true. But then I think if D equals C, then C cancels out, doesn't it? I think it's simpler than that. Because if D equals C, basically, if D equals C, then basically it means they cancel out because you can factor these out. So R is really just X times A plus B times. It's good to reduce stuff, divided by E. And we're saying that E, I mean, that's the same as doing e to the minus 1 times XA plus BY. XA plus BY, which I can easily calculate. So, okay, cool. So I think actually this makes more sense. So wait a second. So E is for the states where it's not equal. And I think that's wrong. I think this should be Kronecker products. Because you won. The thing is, if you this is supposed to be more generic. So if here we have more qubits, right? There's just a 1, a 2, a 3, whatever. Like it goes farther, right? Oh no, wait a second. That one happened because if they're not equal, that's when it should be. They should be all equal but one. So I think that's actually wrong. If they are not equal, then we shouldn't be calculating these things here. Shouldn't we be calculating these things regardless? No, because, okay, so if the nodes are equal, then it's C. If they're not equal, then, yeah, that's okay. No, that is correct. The thing is, let's be real. We don't need these because the assumption is there can just be one element that is not equal. So actually, I can just simplify these way more than I thought. Oh, that's good. It's good to revisit this stuff after a good night's sleep. Yeah. We don't need all that. You're right. We don't need all that because we don't need to do all the multiplications and stuff. But for C, because they might be equal. So if they are equal, that's an awkward way of doing that. But yeah, if they are equal, I need to here. I actually need to do it. So here I do need to say if this not is none, if this is none, then do this. Else C equals. I think it's NP cron, and I think I need to do C with these. I think it should be the Kronecker product because the idea is these thing grows up, right? It grows up in terms of it's a bigger and bigger state. Yeah, but I don't need C. That's the point. I don't need C, right? Because C is okay. Then that makes things life easier. Okay, so I need C. I don't need because C is there. So I'm just saying. Okay, let me just think about this for a second. Okay, so X times A times C plus Y times B times C, right? Again, those are states and those are complex numbers. So those are actually matrices of like column vectors of complex numbers. So if I add these things up, right, that will be the wave function describing these. Must be equal to R times E times D. E being the sum of these and D being sort of the merging of these, but then D equals C. And so C just factors out of the equation. Okay, cool. So actually, it's even easier. So C is not needed. I just need to capture that. Z is not needed. X and Y are the amplitude, so these are the complex numbers, right? Cool. And so what I need to do is, I wanted to make an example. So let's make an example. Let's see if I can make an example down here. Okay. So let's say that we have the state. Let's say we have the state, right? Let's make a simple one, right? Just the first simple one, right? 0, 0. And this is like square root of 2, square root of 2. And so this is merged into 0, 0 plus 1, and then what's this z, right? So according to the function, or according to the equation that we've just built, is that, you know, well, I mean, so the part that's equal, C, we don't care. So we care about the part that's different. So A is basically an array that's like 1 plus 0 I, right? And 0 plus 0 I. So this is A. B is 0 plus 0 I, 1 plus 0 I, because it's 1, right? And then X and Y are equal, which is basically 0.707 plus 0.707 I, right? Just because, I mean, this is the, you can check this out, but this is the regular stuff. It's 1 over the square root of 2. Yeah. But it's like a complex number. This is xy, right? So what we're doing now is, okay, and E, so what is E, right? So E is the, okay, so E is this thing here. So it's the plus state, which means that E actually is this 0.707 plus 0.707 I 0.7. No, what am I doing? Yeah, I think that's correct. 0.707 I. Is that correct? I think that's correct. Let me just double check. So let me just double check. Right. No, it's plus 0. Oh, sorry. The no. I'm mixing things up. It's because, so these parts are all 0. You're right. So these parts are all 0. So these parts are all 0. Sorry. The same here. Yeah. They're all 0 because yeah, there's no imaginary component. It's just that they're both 1 here because it's an array, and this is just a number, right? So good to correct that. Good to double check that. Plus 0 I plus 0 I. Good. And now we have to in theory do is, so the transpose of these, right? And then x times, so basically x times a is going to just turn, is just going to turn into like, this is just going to turn into 0.770, right? Plus, so it's just like basically these, right? So 0.7, blah, blah, blah. Yeah, so basically, yeah. So if I transpose that, the multiplication of this transposed or complex conjugate and these, it will just be 1. This means the amplitude, this means z is 1, which kind of makes sense because at the end of the day, you've already put those things down here, and so you're just merging them, and you want that to be correct. So I think that seems to work for these. Yeah, I don't know. Let's see. Okay, so I just need to make the conjugate transpose of that, and then so it's TE, and it's just, and TE, and it's the normal product. So and then x times a y times b. So I should print E, print A. Let's print A and B, print X, print Y, print E. Then print TE, and then print that. Okay, cool. So maybe I should just A. So if I do this, so this is going to be the result. This is going to be T, this is going to be E, this is going to be Y, this is going to be X, and this is going to be B. Yeah, I forgot the commas everywhere. That is awesome. Okay, so A is these, B is these, correct? X and Y are these. Okay, so I think TE is correct, but then what does not work well is these. Only integer slices with another next integer errors are valid. Index error, come on. Is it really, is this really the issue? Simplify recursive. Oh, come on, you want, I mean, oh, again, it's A. Is it AMP? It's AMPS, exactly. No, and also I need to change the print statement. And I'm so dark you can't even see me, but I mean, who cares? Amps. Oh yeah, baby. Look at this. Look at this. Oh wow. Okay. So what is the problem now? This seems to have worked. So this is the result. And can I reshape array of size 4 into shape 2, 1? Okay. Why do I have an array of size 4? So this works once. So now Q0, Q1. I mean, okay, what are we doing? So this seems to work correctly, right? So remember the case, right? So let's remember the case. We've got 2 qubits. So that's what the amplitude should look like. Print result. Yeah, I was thinking so NBD being 0. We can merge these. Simplify recursive, and so it's basically now we've got some issue with a reshape, and then this happens because of E. Okay, so because of E. Is initialized and known. Why would these have size 4? Why? That makes absolutely no sense. I mean, I can replace these by that, so it doesn't break, which is okay because I think that we would have to do that anyway. But still, key error Q0. Okay, because Q0 is not anymore, because no, something's wrong here. Something's wrong. Q0 should always be there. So we do for all the qubits in M1, right? M is already given here, so go through. Okay, so what does M in every iteration look like? Print M. Print M, print amps, okay, that's weird. It's just okay, 1 and it already breaks. So this is it happens here. A. What is the problem? Hmm. For n in ME1. Oh, oh, I get it. It's not nodes here. It's these. It's the length of these, right? It's the length of these. That's why it's complaining, because here it's not defined. Okay, so complaints. Q1. Missed it somewhere else. Nodes, oh yeah, they're definitely here. Cool. Okay, so now it does stuff. Okay, so now it does the two edges. It does two iterations. Interesting. And now what's the problem? Counter shapes, it's shape 2-1. But why? If I'm what if I'm using the length of nodes, how can that shape 2-1? I really don't get it. I really don't get it. Hmm. Nodes n. That's weird. So I normalize. So can I print nodes n and then print okay. Oh, why is it a matrix of 2? I know, sorry, it's 2. No, it's 2. It's okay, it's correct. Length 2. Length 2. Because it's already in that shape? I don't get it. Is it already in that shape? Why is it already in that shape? Oh, because it's already reshaped. Oh. Huh? Okay, so I reshape it once already. Huh. No, that's weird. Okay. Print notes n. I don't have to reshape it because if I reshape these two and I do these, then that already has the right shape. I get it. So this is just, I get it, nodes n. That's the point. Already has the right shape. I think that's the idea. Either these, or I just, reshape that. Yeah. Okay. Oh, still breaks. Here, key. Oh, what? Q0? What? Why? Come on, I'm so close. Check which qubits are entangled. Yeah, Q0. Why is not there? Q0. Q0, Q1. Edge. Okay, so let's okay, I think M is the problem, maybe. Yeah. I think it's the variable name. Is it? Create edges. Is it in create edges, or is it these? Where's these? Yeah, it's in create edges, okay. So let's print M and see what happens. Now it seems like the simplified recursive has finished, so I think I'm not printing anything else in there. That's all correct. Oh yeah, these I'm printing still, so I don't want to print these. Cool, so I'm printing M. What happens now? What is M? So I've got edge, so this is the merged edge, Q0, Q1, then another edge Q0, Q1, then another edge Q0, Q1, then another edge Q0, Q1. So what is the problem? I have edge and qubit. And so this is complaining that oh, I think I gotta, okay, I think I know what the problem is. I gotta do probably gonna do like these and then make the assignment actually. Okay, yeah, now the next error. Dictionary has not to recount. If this will work, I'm gonna be super happy. Create edges. Okay, count. So what am I counting here? Check which qubits are entangled. So for qubit in T, if the qubit is oh, what am I doing here? So I'm checking the keys. I'm checking the first. Okay, so I'm checking the. So I'm checking the keys. Checking the first key. No, wait a second. So check which qubits are entangled. Because I want to get which ones are non-entangled. And I want to check for, each edge if that qubit has got the same node value. So what am I comparing here? For qubit in T, I want to count how many different values were there, right? Okay, I get it. Yeah, so this is counting how many elements of these, how many elements like the first one are in there. Exactly. Yeah, I think it's a bit like I can it's fine. I can I can do like qpref is basically tq tq keys 0. So I get the first value, and then I say for e in tq, for edge in tq, right? Equal true. So all equal to, then so if t q e is different than qpref, like if I q first, it's fine. So if I find anything that's different than the q first, then, well, that's stupid. Yeah. So all equal is true if they are the same. And so if no, that's not what I want to, because I don't want to. Oh yeah, and if all equal and this is still equal, then all equal. But if suddenly all equal is false, then this will stay false, and then at the end of the loop I just say if all equal, then it's not entangled. Exactly. So what I'm saying is I'm getting the first value, I'm setting the all equal true, and then I'm iterating, and as if I find something that invalidates this, then it's going to just keep all equal false forever. And okay, what's the problem now? Dict key is just not subscriptable. Oh, come on. What am I doing? What am I doing? Where am I? Create edges. why I get lost so much? So Q first is come on, I'm just tired of I don't know enough. If Q first is none, then we set it, right? Q first equals TQE else all that stuff. I'm just I don't want to waste time looking for the right ways to build these loops. I don't care. So if the Q first is none, then we initialize it, and then we just check the rest. Okay, what's wrong now? Okay, key error. Okay, cool. So there's something in here. Create edges. Yeah, okay, of course, this edge is not here, right? Now, create edges needs the new amplitudes. Does it have them? No, amps. And so what it should do is it should not check on edges, but it should check in amps to get the amplitude, what is just already what's in there. Yeah, perfect. So, cool. Now create edges. So how do I return these? Wait a second. So simplify recursive returns what? Can I just return a tuple? I think that works in Python. Return m and amps. And so this means that here and simplify, I get m simplified and amps simplified, right? Delete edges, and then here I say amps simplified. They are simp. And then amps simplified is what goes in here as amps, and then that should work. No. Key error. Oh, come on. Create edges. Create edges. What am I doing here for E in M? Hyper edge. Edge. This is edge. Okay, no, it can be E. I just have to use EUID for these. EUID for these. I think that should do it. H26 doesn't exist. Oh, I need to give it the. I need to give it the UID. AH26 is a new one. That is the problem. The thing is, can I give? Because those are going to be unique. So can I give a hyper edge? Basically, UID. So what I'll do is, if UID is none, then then get this one, else self UID equals UID. And we're going to assume that we know what we're doing. And so when I create the hyper edge here, in the create edges, I'm actually gonna give it a E. And I think we should change this and not override E, because that's really stupid. So edge UID, edge UID. Oh, look at these. It doesn't break. That is awesome. Whether it's correct or not, it's another thing. But it doesn't break. What? I think that's not correct. I think the amplitudes in here are just wrong. But let's take a look at it's 4 nodes left, which I think makes sense. It's just why is the delete edges not working well, or what's the matter with that? Because there's an empty edge in here and there's the system edge. Something's off. Again, remember the expected result is that we have 2 branches, right? Because we have Hadamard, and then we have a CZ and a CX. So so basically we have a 0, 0, then we have like a plus, plus, then we have like a 0, plus, and a 1 minus, and then we have a 0, 0, 1, 1, 0, 1, and then 1, 0, but this one has a minus 1, and if we merge these two, then we have a 0 and a plus, and if we merge these two, we have a 1 and a minus, right? So we should really have these 2 branches, which kind of makes sense, but they should still be somewhat entangled, and it doesn't seem like they are. But let's take a look at least if we print, if we don't draw it, but we print self nodes, self edges, self system. And I think I'm going to leave it here, even if okay, so I'm stupid. Okay, so for n in system nodes, print n. For e in system edges, print e. Thank you, genius. State and then amplitude, print, print. I think I should make that a function. Print nodes. No, print edges, and then print nodes. So system print raw. Okay, so print raw, call it, and then it's just a matter of print raw self. It's just this. Not system, now it's actually self. Why is this so slow? I don't know. Okay, so nodes is like, yeah, that's awesome. That's actually correct. Look at these. So one is a minus, but it has the minus in the zero component. Oh, wait a second. Why are these things like that? That's the reason why I get this shit here. Okay, so it seems like I'm... So I think what I should do is I should be back at that is nonsense. Wait a second. That is total nonsense. Okay, what I should do is the following. Yeah, that's the problem. So this should go here. So it just happens normally. Then ABC happen, like these things just happen as, you know, oh, what the heck? What have I done? Exactly, and I need to reshape that as well. So I reshape that to have, you know, these, but like notes over here, I do actually reshape like these. But then I don't, the actual assignment to notes, which is what then goes to the result, doesn't get reshaped, because if this would get reshaped, then we'd be in trouble. So we need to just reshape this just for the stuff in here. Oh, no, it doesn't work. And do one. Okay, have I made another mistake with the reshape there? Does it does reshape numpy change the actual shape of the array instead of just returning? It actually gives the okay, no, but A stays. So why is what's wrong here? Um, Notes and is this notes sheet, man? I mean, so so notes, 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 notes. These are all just oh man. Hmm. Why does these? Why is this printing a column? Why is this? Why does the damn last operation print a fucking 2 by 2 matrix? This I don't get it. Why? So print these. Print that, and then print these. So yeah, okay, but that's just all chill, man. I mean, it's all good. It's yeah, and then the amplitudes of. Oh, I think the problem is with the amplitudes, is it? I think these amplitudes need to be reshaped. Yeah, that's the problem is here. Okay, that the result of this is not what we want. That should be a number, not a matrix. Okay, so but what this means is the issue is okay, so the issue is with the function. No, the issue is with the calculation. That's the issue. This is the issue here. That this is not a. So what if I just give it E? What if I just give it E? Okay, that's better, but we still need to reshape it. So I don't know why. Maybe that's wrong, but okay. I thought we had to transpose that. Okay, but E is already. Oh, because E is already like that. It's like already reshape. I don't know if it's the right thing to do. I get it. Okay, so it should be TE, but it should be, but you shouldn't reshape that. What you should do is you should do the transpose. So now it should be correct. Yeah, now it's correct. Now it's correct. I think. Yeah, but that's not. That's something odd. Like that's not good. Hmm. That should be a number, not an array, right? So that's the. So I think there's something. So if I print transpose, I should get a row vector. Okay, and I don't. I should. So, but then it was. So wait a second. So it was correct. So I need to reshape it, and I need to transpose it. I need to reshape it because I want this to be vertical, but then I need to transpose it because I want this to be. Transpose. That's correct. That's okay. It's just one element. Something's wrong with these. So the transpose is correct now. Um, should I just do like this? But now it's complaining that what? Size 2:1. Okay, I gotta probably fix that next time. It's so there's something off with, and I got it to work, but there's something off. There's something off with the way these works here. Yeah, what's off is that I get the E is just nodes, which is not transposed, right? But E needs to be, it's a row, and I want a column, so I want to do the reshape, right? Oh, I gotta reshape it here as well. That's the issue. So I reshape it here as well. No, I don't have to reshape it here. Ah, oh, damn it. Damn it. I don't have to reshape it here. No. Because I'm just assigning it. I need to reshape it for E because E is that, like that's what E is. E is this thing here. I need this to be a column vector. So I can then take the transpose of the column vector. Oh man. Yeah, the problem is here. The problem is that this doesn't have the right shape. So X is a number, so this should be column, this should be column, so this should be column, so this is row times column, right? If I print these, yeah, column. So transpose times column. So it should be correct. So if I do transpose times column. Okay, but that's not correct. Why is it not correct? What is this multiplication doing? Should I just do... maybe I should do the dot product. Maybe I should use dot. But I thought that's the same. So I thought it's MP dot. Oh yeah, there you go. So what is the multiplication doing? So I need to do the dot. I need to do the dot, and I need to get the element there. Okay. Yeah, baby. Awesome. Cool. And now I can print these, and I think we got it. Yeah. So there are 4 nodes. Okay, no, but it's not correct, right? Because this is still somewhat lost, like the edges are not, these cubes are not attached to the right edges. Let's take a look at these. So when we create the edges, delete node, delete edge, apply, simplify recursive, create edges. Add node. So if Q is not a not entangled, self add. Okay, so this is not working. I think it thinks they are all not entangled, maybe. That's the reason. So all equal is true, and then we take a look at all the edges, right? If q first is none, then q first equals this value. Else all equal equals all equal and TQE being the same as Q first. So this means they're all equal, right? Because they're still equal, like, you know, like the same. So if all equal, then append Q to non-entangled. And if I print non-entangled, yeah, they're both there, which is wrong. Why? What is wrong with these? So for Q and T, right? For Q in the T matrix. And then for edge, this is the right value here, T. So for E in M, for Q in ME, oh, I think there's a mistake in here. Oh, yeah, I'm over, I'm overriding the. How do I do that in the other if uh, if I think I do this somewhere else. I think I do this in the simplify. If it's in the keys, yeah, exactly. Create edges. So I'm basically overriding these accidentally. So that is why. So if Q not in T dot keys, right? Then do that. Else just do the assign. No, or just do the assignment regardless. What's wrong? An array. All equal. Oh, okay. These are the nodes, I see. So because these are complex numbers, so I think I should compare the imaginary and the real. Oh no, I have self equal, right? State equal. Okay, I have this state equal, so I can use that in the create edges. Self state equal. Exactly. There you go. Oh yes, there you go. There you go. It worked. It worked. It worked. It worked. It worked. It worked. Can I see this? Yeah, okay. Let's see. So one is, yeah, it worked. It worked. It worked. So the zero is a plus, the zero is a plus, and the one is a minus. Yeah, cool. Gotta clean that up. But basically the simplification seems to work. Voila. And even the numbers, right? Like they just like that's the point 0.7 that we wanted and all that stuff. So